ionic compounds, we can now sort of talk as a class of compounds. Can I recognize them in their chemical formulas? Can I recognize them in their name? And sort of how do I represent them? Again, one way to predict ionic compound formulas is to use those Lewis structures, but the more typical way is if I know the ions that the metals and the nonmetals form, I can just use math to figure it out. So in these particular three cases that I've shown, if I had a +1, something that makes a +1 ion and something that makes a -1 ion, then I just need one of each. For instance, potassium is group 1 metal. It forms a +1 cation. Bromine is a group 17 nonmetal. It forms a -1 cation. So when I have potassium and bromine combining, they will form an ionic bond with the ionic compound with the formula KBr, one of each. However, calcium is a group 2 metal, so it makes a +2 cation. Chlorine is a group 17 nonmetal, so it makes a -1 anion. Note that 1 and 1 is not going to work. If I just had a +2 and a -1, I still have excess plus charge that's not canceled out. I need extra negative charge, so I need 2 -1s and 1 +2, which means I need 2 chlorines and 1 calcium ion. So this would have a formula of CaCl2. We always put the metal ion first. So Ca, I only need one of them, Cl2. And then if I had something like nitrogen, which makes a -3 ion because it's a group 15 nonmetal, and sodium, which is a group 1 metal, makes a +1 ion. Now this needs a 1-to-3 ratio. I need 3 of the sodiums with a +1 charge to cancel out that -3. So the formula for sodium with nitrogen would be Na3N. So we can use just figuring out the charges. I can draw them like this. But again, figure this out is really important, so I'm going to show you a few different ways. Another way of drawing that same general idea is to use something called ion blocks. So I've created some ion blocks with +2, +1, +3, and the negative ones. But again, the first part is you need to say which elements am I using and what is their charge. So in the ions section, we really talked about how do I tell whether, if I'm talking about calcium, how do I know that calcium is a +2? I have to look at its position on the periodic table and know that it's going to make +2. Then I would grab +2 ion blocks. And then depending on what I'm pairing it, if I'm pairing it with something from group 17 nonmetal that makes -1 ions, like chlorine or bromine or fluorine, I would get -1 blocks. And I simply pair them up till they all match up and there's no extra bumps and there's no extra holes and they all match up, and then I know I just count how many I need of each type. So I could use this as a way to determine. And sometimes if you're a visual person, doing this a few times really helps you kind of click with this. Other people are more mathematical. So another way to do it is to write down the chemical with the charge of, I have to figure out what charges they make from their position on the table, and then use that and just take a guess at what subscript it might be. So I put the cation first and I put the anion next and just take a guess. And when I take a guess, I do know that to make sure that it is all neutral and the positive charge cancels out all of the negative charge, I can find out by taking the charge times the subscript. So 2 plus times 1 would be 2. 1 minus times 2 would be -2. +2 and -2 do cancel each other out. They're the same size but opposite in charge, and so this would be neutral. So we can always use this checking rule. The subscript of the positive ion times the charge of the positive ion is the total positive charge. Has to equal the subscript of the negative ion times the charge of the negative ion. And we can use this. However, we can make some lucky guesses of what those subscripts are. This is just kind of stepping through. We would pencil in the charges that we guessed at, multiply them through, and double check. If they weren't equal, we'd have to guess again with another number. But the best subscripts that we should guess at would be the subscript that's the charge of the other ion but without its sign. So for aluminum, I would guess 1 because the charge of chlorine is a 1 minus. So I just take the 1 part and I make that the guess for the subscript. Same thing with chlorine. I'm going to make the guess be a 3 without the plus sign, just the 3, and I'm going to try those as guesses. It's always going to cancel out in charges, because they're really the same two numbers multiplied in different ways. So I check, and sure enough, they work. And we kind of call this the crisscross method because the charges are usually written as superscripts, and if I crisscross them down to the subscripts, that ends up working out. You do have to be careful that when you're done, you have to look at the 1 and the 3 and say, can those be reduced? In other words, if it was a fraction of 1/3, can 1/3 be reduced? No, it can't. I can't divide both that 1 and that 3 subscript by some common number. So I would leave it alone. But sometimes you can. And if so, you would want to reduce them to the lowest set. So when I'm done, I would need to clean this up because I put those charges in there temporarily just to kind of figure things out. And then I need to clean things up. So when we draw an ionic compound formula, we don't show the charges. They're implied that there are charges there, and you're just supposed to know what the charges would be based off of where that element sits in the periodic table. They don't show subscripts of 1. So if there's no subscript, it's implied that the subscript is 1. They always show the lowest set of subscripts. So I always want to double check, can I divide them both by some same common number? And so when you're finished, you want to rewrite things clearly. Also, we use parentheses if it's a group of things. We put the polyatomic ion in parentheses and any subscript needed outside the parentheses. If there is a subscript of 0, I don't even need the parentheses. But we'll see that when we really sort of see some polyatomic ions. So when we go to name them, we simply name them by what the ions are. Cations are simply named for if they are not polyatomic, then the cations are just named as the name of the element, if it has only one possible charge. So aluminum, if I go looking on the list, it is not a main group element. Well, it kind of is. It's group 13, but it's kind of one of the transition metals. And look it up, but it's always +3. Therefore, I don't need to indicate any charge in Roman numerals, so it's just called aluminum. Ammonium is this NH4. If I look on my polyatomic ion table, it's a cluster of things, but it has a charge, so it has a positive charge, and it's called ammonium. So I just use its name. If it's a polyatomic ion, I just grab it from my chart. You will have to memorize them for the test, but for now you're using a chart. However, for copper, it's a metal, and I name it by the name of the metal, copper, but I have to include the Roman numeral 2 because this one has a +2 cation, and I have to show the 2 of the charge in Roman numerals because copper sometimes makes a +1 cation. On the anion side, the way we name anions, if it's just a single element, we name it by changing the ending to IDE. So nitrogen becomes nitride. Chlorine becomes chloride. However, I also have some groupings of atoms that are polyatomic ions that have their own dedicated name. So if it's a polyatomic ion, I have the reserved name for the polyatomic ion for SO4 with a -2 charge, it's sulfate. So the naming of it means I have to first identify the ions, the positive ion and the negative ion. And on the positive ion, I have to classify, is it a metal with one charge only? Is it a metal that can make more than one charge, or is it a polyatomic ion? And on the anion side, is it a non-metal element, or is it a polyatomic ion? So here's another flow chart, kind of breaks it down in a different way. As you practice these, once you're sure that it's an ionic compound, trying to name it, you really want to step through, like this case, that case, all the possibilities. Here is that polyatomic ion list. Again, this is the one from the need to memorize list, and these are the ones you want to be looking for, and you really want to get familiar with seeing them. You need to know the grouping. So for instance, ASO4, you need to know the charge, because the charge won't appear in the ionic compound. You need to know ASO4 represents arsenate, and then it has a -3 charge. You need to know CO3 is going to have a charge of -2, and it's called carbonate. So take a time and be looking at these because we're going to see these in a lot of compounds and you want to be able to recognize them. This is something you do need to memorize. If I have some ionic compounds, you can see with polyatomics, here I see NO3 is a polyatomic ion. There's 2 of them in this particular situation. If we go looking up the charges, NO3, nitrate ion, has a -1 charge. Magnesium is group 2. So it has a +2 charge. So that's why I need two of them. But because I need two of them, I have to, if I didn't have the parentheses, it would say NO32. And that would suggest 1 nitrogen and 32 oxygens. But it's not. It's two groupings of NO3 polyatomic ion. So I have to put the polyatomic ion in parentheses and the 2 after it. In the second compound, I have NaNO3. I have 1 sodium plus 1 ion and 1 NO3 nitrate negative 1 ion. Because there's only one of them, I don't need the parentheses. So it's a little bit harder to tell that there's a polyatomic ion there. I could also have a polyatomic cation and a polyatomic anion. One of our primary positive cation, polyatomic cations is ammonium ion. You should recognize it because it does trick you. It's doesn't look like a metal, but it's a polyatomic ion. So this is an ionic compound. So ammonium is that first one, and then I only need one of them, so no parentheses. Same thing with the nitrate, only need one of them. So these are what you might see for some of these polyatomic ionic chemicals. Just a reminder, so when you are doing this naming of an ionic compound, you first want to begin to make sure that it is an ionic compound. So we're looking for, is there a metal in the name, or when in the formula? Is there a metal in the formula? Do I see a polyatomic in the formula, and does it not begin with H? So I'm looking for those groupings to help me decide. I don't want to be naming it if it's really a covalent. I don't want to use ionic naming rules. So I'm looking for those polyatomic ions, and I'm kind of grouping them in my mind. Any ionic formula with 3 elements kind of has to include a polyatomic ion. So can I find that grouping, find that polyatomic on the polyatomic table? If I have a metal that's a transition metal, I want to be careful. I'm going to have to make sure and figure out what its charge is, because I have to include in Roman numerals what its charge is. If it's not capable of having, if it only forms 1 ion, I don't need to figure it out because it's only one possibility. But if it's copper or iron or chromium or titanium or any of these other ones, I need to figure out what charge it is before, so that I can include that charge in Roman numerals. That becomes a little bit of extra trick. Here's some practice of writing chemical formulas, writing chemical names from the chemical formulas. We'll do those in class. Once I have the name, if I'm given only the name and I want to do the reverse process and come up with a chemical formula, it's kind of like what we were doing earlier when we just gave you the 2 ions and you did the crisscross. However, extra trick here, I have to figure out that it's really ionic. So I'm looking, does it have a metal in the name? Or do I see a polyatomic ion in the name? I'm looking for that. If I do, then I'm going to write the different symbols. So I'm going to start with writing what is the symbol of the cation, what is the chemical symbol, and what is its charge. I want to write for the anion, what is the anion, what is its element, or if it's a polyatomic, what is that formula, and what is its charge. If it is a polyatomic formula for either one of them, I want to include it in parentheses and put the charge outside of it. That will be a little less confusing to you. And then I'm going to use algebra or crisscross to come up with a guess of the subscripts. I want to double check the math that it cancels out. Then I want to double check, can the subscripts be reduced to a lower number? And then I re-clean it up. Get rid of the temporary charges, get rid of any subscripts that are ones, get rid of any polyatomic parentheses that aren't needed because the subscript is 1, and kind of clean it all up. Over here on the right we see an example. So the name is copper 2 sulfate. I see copper is a metal. I know that this is an ionic compound. Copper has a chemical, it's just a metal, so it has the chemical symbol Cu. The 2 represents the charge. I don't need to go look up on a periodic table because it's telling me it's a charge. So it's 2 plus. Then I go looking at the second part of the name. The anion name is sulfate. I recognize that's the name of a polyatomic. SO4, I put it in parentheses, and then I get its charge is -2. I put that outside of the parentheses. So I have +2, 2 minus. I'm going to crisscross them down to 2 and 2 without their signs. But 2 and 2 can be reduced down to 1 and 1. They can both be divided by 2 to reduce them to 1 and 1. So now I want to clean it up. I look with that copper. I get rid of the charge. I get the subscript is 1, so I get rid of it. So I just write copper. For the SO4, because I get rid of the charge, I get rid of the 1, but because it's got a 1, I don't even need the parentheses, so I get rid of all of it. And I just have CuSO4. And that would be how I'd write the ionic formulas. A couple of hints. Here's a flow chart that may help when you're writing the ionic compound formulas from the name and stepping you through part by part. A couple of warnings. Make sure that the formula is really ionic. Again, it's going to have trouble if you're trying to do this for a covalent name, writing an ionic formula. Write the chemical formula for each ion. So you're going to put the charge in temporarily because you need to use it to do the crisscross. And then if there's a Roman numeral given to you, that is the charge. Otherwise, you need to go look up the charge on a table, and then you'll do your crisscross. Have fun. Here's some practice. We'll do those in class.